Is it safe? Is it safe to emerge from space? Well, welcome to space, folks. Welcome to space. And congratulations on realizing the Smash News Network least busted name of news exists. What's that? You want solar imagery and space weather? Okay. There's the past 24 hours from the SDO's perspective. And you might see a massive filament coming back around from behind the limb. A great example of how a filament can turn into an Earth-directed coronal mass ejection when it's not even visible on the Earth side of the solar disk. We'll let you know later in the video if that one is an Earth-directed coronal mass ejection, so make sure you stay tuned for our CME section. Here's a close-up of that filament. What a spectacular image. It was the largest filament we've covered on the channel in over 6 years of daily space weather videos. And that one was unwilling to stay behind the limb. Dag. Here's the equatorial zoom, and you'll see lots more filaments draped across the Earth-facing portion of the solar disk. Some of those even got named after living people. At least one of them did. We'll get to it. Also, a new sunspot just rose once again in the northeast. There's the southern hemisphere, and there's another massive filament down there south of the Earth scale. It's hundreds of thousands of kilometers in length, and it's becoming a prominence there, down in the southwestern limb. And we've got lots more to talk about, so don't miss the rest of our coverage, and don't forget to press the like button. If you're new to the channel, press the subscribe button. You've found the world's most comprehensive daily space weather channel, as well as the most detailed solar imagery you'll find in the known universe. We even do meteorology segments on the daily, empowering our viewers to know how to forecast the weather all the way from the sun down to the lower 48. Thanks to our new YouTube subscribers. And even if you're an old YouTube subscriber, press the like button, press comment. If you've never left a comment on the channel, leave a comment. Join us for our live premiere chats. You will get a wrench. You're getting a wrench, and you're getting a wrench, and you're getting a wrench. But don't moderate, folks. Do not moderate, as we are indeed free speech purists. We encourage all legal speech. And yes, I'm transparent. My shirt is, my chest is full of space. Look at, oh my God, the Galaxy Cygnus A is inside of me right now. Jeez, oh whiz. Help out the channel by visiting the homepage as well, smashomash.com. You can assist us with clicks if you're unable or unwilling to open your cobweb-encrusted wallet and send us a few bucks by becoming a member of the Smash team, or by visiting our paid affiliate/sponsor links. Again, visit us on social media. Press share, press comment, press like, etc. Press all those things and then type stuff. Don't just leave emojis. Type actual stuff. And we appreciate your comments. We read every one of them, even if we're unable to respond to them all. Today's featured product on the Amazon store, it's amazon.com/shop/smashomash is Cameron's Coffee. It's dropped in price once again. Apparently the price of this is pretty varied, so check back in periodically. That is a 4-pound bag of organic whole bean coffee from Cameron's. Organic whole bean coffee. When we switched to organic, it stopped making us jittery. You can even find the very cup that I drink from on there. Check it out. There it is. Ta-da! That's on the Amazon shop in the coffee selections as well. So it's a set of 6 colored glass mugs. You might like that. I don't know. But switch to organic coffee if you're still drinking that crap from places like Starsucks. I mean, really? They're not selling you organic coffee, folks. We refuse to drink coffee that we didn't brew ourselves. Organic whole bean Cameron's Scandinavian blend is what we're currently consuming here at the Smash News Network, least busted name in news. Another way to support the channel is with the Hemp Lucid Shop. Pick up your CBDs through our links. You can find them in the description below this very video, as well as on our homepage at smashomash.com. Thanks to all the kind folks over there at Hemp Lucid. Save a bundle on stress, immune, and sleep stacks, as well as the full stack package. CBD lip balms now back in stock. They make great gifts. Get your CBDs, mushroom gummies, immune, stress, and sleep stacks through our link. If you've never tried them out, perhaps try them out. You can save some dough on mushroom gummies now as well. Again, links below the video in the description and on the homepage at smashomash.com. Other ways to support the channel are through merch, and save 20% on all the merch at the Redbubble shop. I'm currently wearing the most popular selection, our public service message. We can't believe we have to tell people this, but do not pole vault the caldera. There appear to be some unwise people in the world. I don't know. Some unwise people. Anyway, this public service message brought to you at massive personal risk and expense by Smash Staff and I. Of course, my shirt is green, so anyway. Save 20% on all merch items on the merch shop. That's also linked below the video. You can also find the Smasho merch link to the Redbubble shop on the homepage. This one shows off the YouTube URL. Get blank looks at parties by telling people that you are a follower of space weather. In any case, do not pole vault the caldera. Our finest days lie ahead. If you're going on a volcanic vacation, leave the vault pole at home. Last but not least, you can support the channel by becoming a member of the Smash team. Get additional content, especially at the gold level. There's also a silver level. There's even a bronze level. And we send email alerts about videos just like this one to all of the levels, because people don't get notifications on certain video hosting sites which will remain unnamed. So, yeah, I mean, we made our own subscription services site. We launched it officially back in October of 2021. Did you know that in 2018 a crack YouTube unit was sent to social media prison for a crime we didn't commit, and that we promptly escaped a maximum security social media stockade to the internet underground where we survive as producers of fortune, and that if you have a problem and if no one else can help and if you can find the content, maybe you can hire the Smash team? It's true, folks. It's true. Anyway, here are some images from SDO, and there's maybe a coded message down there at the bottom. Let's take a look at that. Oh, look at that, folks. Oh my God, NASA must be sending a coded message. I'll leave that pause for a minute just in case you want to try to decode that. Yes, it's Friday the 13th, folks. Friday the 13th, so something to be spooked of. It's a coded message from NASA, perhaps. Oh my God. Dear God. Anyway, that's SDO Continuum. Sunspots here mostly stable for the past 24 hours. We do have one new group rising there in the northeast that you can see a bunch of missing data there on the SDO as well. Some errors on the SDO site. Let's move right along to briefly look at what's going on Croissant Earth. Yeah, Croissant Earth. It's shaped like a croissant, not an oblate spheroid. Stop believing lies and join the Croissant Earth Society. Khrushchevskoy is erupting in an explosive fashion and producing an 18,000-foot ash plume, 14,000-foot ash plume from Shiveluch. Both of those on the Kamchatka Peninsula. Sakurajima, 6,000-foot ash plume, 7,000-foot ash plume from Subanose-jima. Mayon. Don't be a moron. Mayon is producing an unknown volcanic ash plume once again over Luzon Island, Philippines. Dacono exploding, 7,000-foot ash plume. Popocatépetl exploding, 20,000-foot ash plume. Popocatépetl now back on the list. Go ahead, say it aloud, folks. You know you want to say it. It's on my bucket list. Popocatépetl. Santiaguito, effusively exploding, and it's making new real estate in Guatemala, as well as producing about an 11,000-foot plume of volcanic ash, flight level 110 over Santiaguito. Fuego in Guatemala exploding, 16,000-foot ash plume over Guatemala from Fuego. 21,000-foot ash plume over Colombia from Nevado del Ruiz as it explodes. Also Sangay in Ecuador exploding, 22,000-foot ash plume. Ecuador also features Revenador, possible volcanic emissions there, and sporadic emissions from Sabancaya also. Do not pole vault the caldera. Next, looking at earthquakes. And the largest quake of the past 24 was a 6.0 magnitude. We'll get to it. That's the past 90 days. And here are the quakes that have been shaken in the past 24 of a 5 or greater magnitude. Starting out with one at Kurilsk, Russia. That was a 5.1 at 22:33 Universal Time yesterday evening. That one closer to Japan than to Russia. Philippines also had a 5.2. That was at 0:24 this morning on Friday the 13th. South Sandwich Islands had a 5.3. That very actively shaking region there has been shaking for months and months, if not years. South Sandwich Islands, a 5.3 at 2:25 this morning. Largest quake of the past 24 was a 6.0 south of Australia at the West Indian Antarctic Ridge near the Antarctic/Australian plate boundary there. 6.0 was at 3:44 this morning. And then Fiji had a 5.2 at extreme depth over 550 kilometers, estimated depth at 8:54 this morning, that 5.2 magnitude quake at Fiji. And then last but not least, Japan had a 5.0 at 9:59 Universal Time this morning, and it's time to head back to space. Now we've got some more sweet images for you here. This is 193 angstroms plus 171 angstroms, showing both the extended corona and the lower quiet corona. So that's a great composite wavelength. I like it. Let us know in the comments what you think. I would once again direct your attention to this southwestern filament. It's fairly picturesque. And there's a close-up of that. And again, it is hundreds of thousands of kilometers in length, stretching all the way almost to the edge of the frame there on your screen left. There's the equatorial view. There is a coronal hole here rotating into the western hemisphere at this point. And we've also got, like I said, that new sunspot rising in the northeast and lots of plasma filaments. And there's that new sunspot. It just rose over the northeastern limb as we did show prep. Continuing right along to the 10.7 centimeter radio flux, which is now down to 157 solar flux units. And if you're new to the radio flux, it comes out of this area, the upper chromosphere and lower corona, just above the surface of the closest star. And it is proportional to sunspot number. That's why we follow it. Discovered in 1947 by Canadian radio enthusiasts using old World War II radio equipment. They discovered the 10.7 centimeter radio flux. It's been monitored ever since. There you can see how proportional that is to the sunspot number. The black line is the 1-year radio flux. The red line is the sunspot number. Expect more higher highs and higher lows to continue, since we are still not at solar maximum. No matter how many people tell you that we are at solar maximum, we just aren't. I'm not going to get into it today, but check it out. We have a massive increase in the solar wind. So, magnetic fields much stronger than they've been now that Earth is in a North Pole current sheet. And we may be going into geomagnetic unrest or even mild geomagnetic storm conditions. We'll tell you why here in a minute. Space Weather Enthusiast Dashboard not forecasting any space weather, really. No geomagnetic storms or geomagnetic unrests there forecasted by NOAA. Moving right along, here is our Geospace Magnetosphere movie. This is the past 4 hours of Earth's magnetic moment from space. And a big uptick. A big uptick in the solar wind parameters. So we saw an uptick in the solar wind density and the magnetic fields, which we'll get to here in a minute. Much stronger solar wind here. This is the last 4 hours of Earth's magnetic moment from space. It depicts magnetohydrodynamic pressure. If you want to figure out how the space weather modeling framework works, head to the Geospace Magnetosphere movie page and click details. There's a link to the space weather modeling framework. You can even download all the software for yourself. It uses a bunch of different variables to calculate that model. Next, Earth's magnetic moment from the ground, and we have had an uptick in aurora here. Again, an uptick in the magnetic field strength, as well as the plasma density and speed. So there's Earth's magnetic moment from the ground over North America. There you can see that significant uptick in magnetic flux density, especially over places like Canada. And here's the full globe view. Let's bring that back. So this all depends on magnetic field orientation. At this point, the magnetic field is plenty strong to create a significant geomagnetic storm. If we see a strong negative BZ signal, that's the vertical component of that magnetic field, we could see mild geomagnetic storm conditions even with the existing solar wind parameters. There you can see a little uptick. That's a negative BZ kicking in. Some significant aurora there. So KP 3. Let's make sure that's refreshed. KP 3.33 is the current situation. Again, we could get well into KP 4 plus without much of a change in the solar wind at the current moment. And for you new viewers, the KP index is an average of global geomagnetism. So check it out. The fields got very strong, and they're actually strengthening here. So current situation is magnetic field at Lagrange 1 is 24 nanotesla, a huge increase. It was at like 5 yesterday, so 24 nanotesla, but we have a positive BZ now, so that decreases the likelihood of geomagnetic storm conditions. We also have seen a slight subsiding of the solar wind density here. Now it's at about 15.3 protons per cubic centimeter. It is subsiding. That looks like a coronal hole high-speed stream for sure, folks. So it made it all the way up to over 40 protons per cubic centimeter then. And just a few hours ago there. But it was not accompanied by a negative BZ. So we had a BT of 21 nanotesla and a BZ of positive 21. Solar wind density now dropping down, and the speed is coming up. So this could be a strong coronal hole high-speed stream. Don't be surprised to see the solar wind speed come up to like 600 kilometers per second here in the next 6 hours. So current conditions now 9.5 protons per cubic centimeter. Solar wind density, solar wind speed here about 370 kilometers per second. We're also seeing an increase happening here as we make the video. In that bottom line there, the green line is the plasma temperature. GOES magnetometers here seeing some major perturbations. That's the past 3 days, and that is the arrival of the density wave and magnetic field of a coronal hole high-speed stream. Continuing on, Earth is now in a North Pole current sheet, as the sector boundary has just been crossed. You can see that quite modest North Pole current sheet. However, strong fields there. So, strong magnetic fields there, and a coronal hole high-speed stream nestled in that North Pole current sheet. Here's our line of sight field plot. And let's switch to coronal holes, since that is what we are getting a heightened solar wind from, most assuredly. So there's our coronal hole line of sight plot. And let's take a look at coronal holes from SDO. There you go. There's the past 24 hours in SDO, 211 angstroms. And we are expecting another coronal hole high-speed stream in a couple of days from this South Pole-oriented coronal hole. The one we're currently getting is showing up a little later than expected. following extended periods of extremely slow and extremely diffuse solar wind. So next is sunspots. And again, we've had mostly stable sunspot situation for the past 24 hours. A little bit of a decline in the sunspot number. There you go. Sunspot number now at about 123, 124, something like that. And here's our flare monitor and flare scoreboard. So a couple magnetically complex sunspot groups here. Most likely flare players are... Well, that's a good question. Most likely flare players are, this one rising perhaps could produce a large flare, and in that it's very close to the limb. Also, this group right here, 3463, that's some sort of an outdated image. I don't know. Number 6 is this group, actually. Anyway, let's just take a look at these. You're going to be able to see which are the most likely flare players because they'll be crackling. So this one here, this sunspot up here, this one looks magnetically complex as well. Don't worry, we'll show the actual magnetogram. That's SDO 94 angstroms plus the continuum. Let's subtract the 94 angstroms to show the raw sunspots. Not a lot of changes there. It looks like one new small pore opened up here, right in there. So that'll likely get a name if it sticks around for another about 12 hours. A couple other spots where there may be some new sunspots forming here. They're all pretty minor. And there's a magnetogram. Alrighty then, so solar flaring has been low for the past 24. That's what we'll go to next. And once again, the likelihood of solar energetic particle events is actually very, very high, because now we've got an even stronger magnetic channel. So the pathway for solar energetic particles is super high. If we do see a large flare, the likelihood of an SEP, a proton event, is even higher than it's been the past couple of days. And it's because we were expecting a coronal hole high-speed stream. It showed up late. So what can you do? Now the solar wind stream, now the coronal hole high-speed stream is showing up in earnest. So that increases the likelihood of SEPs. The X-ray flux, however, has dipped. So, but we still do have some sunspot players that could produce large flares. Background flux is now back below a C-class level at about a B8.3. So B8.3 is the background level of X-ray flux, and it's been quiet for the past 24 hours in terms of solar flares. Let's take a look at our flare wavelengths here. This is 94 plus 131 angstroms. And we'll show you the close-up high-res magnetograms before we move to our meteorology segment, since you too can forecast solar flares. Next, a star chart. We like to know what's going on overhead. Try skyandtelescope.org. You can even follow them on Twitter. You can even follow us on Twitter, as we don't even have 500 followers yet on Twitter. It's pretty ridiculous. Sub 500 followers on Twitter, folks. We've got over 22,000 tweets since 2019 in February when we started the account. Sub 500 followers on Twitter, as we approach 5,000 followers on YouTube. Anyway, Jupiter sitting there in the west right now over Lehigh Valley, PA. Venus chasing. A tiny sliver of a moon. Mercury and the Sun over there in the southeastern skies. Next, how about a solar system forecast? And by the way, if you think planets cause solar flares, make sure you watch Eugene the Philosopher's recent video. Do planets cause solar flares? They don't. Anyway, here's your solar system forecast. Annular eclipse coming tomorrow, and a new moon coming on the 15th. There's where things will be in 1 week. A bunch of planets in a line there will convince people that something's going to happen, even though this has been happening for billions of years in a regular cyclic period. Planets are not controlling the sun, folks. Yes, the planets in the sun, they do orbit the common center of gravity in the solar system. No, the planets are not in control of the sunspot cycles. That ain't the way it works. And let's move on to our astronomy photo of the day, and dag, this is a pretty sweet one. So this galaxy is a really hyperactive galaxy. So the red in this image is depicting hydrogen gas, and the blue is ultra hot, super active, massive stars. So that is a really active galactic nucleus there. This depicts about 25,000 light years. The center portion of a galaxy there, again, the red is depicting hydrogen gas, and the blue is a bunch of hyperactive stars. So very hot stars that produce significant stellar winds, a lot of hydrogen, and a lot of X-rays certainly coming out of that galaxy. That's apod.nasa.gov. Check out this spot. That's a berserk area right there. Look at that. apod.nasa.gov. It is the M33 galaxy, the 33rd entry on the Messier catalog. Moving right along to coronal mass ejections, and we had some pretty sweet ones yesterday. Not sweet enough to produce space weather storms at Earth, though, unfortunately. Those CMEs are not headed our way. We would show you today's imagery from George Mason University. It's just that there is none. So let's switch to our LASCO C2 and C3 here. That was the C2. Now I've got the C3 as well. Let's actually switch to this imagery. This is a little bit better. And Mercury showing up there on the SOHO LASCO C3 coronagraph. There you can see that filament that we started out the video with, ejecting out of the North Polar region, not earthly directed. And we'll also show stereo A to get another perspective on that. Stereo A located right here where this red circle is. Here's a stereo A raw coronagraph on the left and a different imagery on the right. Cameron's Organic Whole Bean Scandinavian Blend. 4-pound bag for less than $25 at Amazon.com/shop/smashomash. It's the John Katowski filament, as one of our viewers and our top supporter of all time named that filament after himself. More about naming filaments here in a moment. That's the view from stereo A. And check it out, filaments. Lots of massive filaments. And we named one, by the way. This one right here. This one down here is known as the Eric Weinstein filament. Weinstein? I think it's Weinstein. Can anybody correct me? So we named that one because of its likelihood to eject. It looks like it may have degraded a little bit, but anyway, let's take a look at these filament eruptions that occurred yesterday, as they were indeed spectacular. So this filament came from behind the limb and it wrapped right around. Looked like it might even become earthly directed. We were monitoring that closely throughout the day yesterday. And yeah, that filament, it just refused to set. It's a drama queen. It had to pop back up around the limb, and it took a long, long time to evolve. Heading deeply to the south, hundreds of thousands of kilometers to the south, and then finally blasting off, expected to miss Earth to the north. There you can see the final stages of that John Katowski filament blasting off. A great example of how a filament from not even within view can become an earthly directed coronal mass ejection. Of course, this one hasn't, but hey, that's the situation. Again, if you want to name filaments after living people, join us over on Twitter. If you've unplugged from social media entirely, we completely understand why that's a thing. Did you know that heliophysics is the basis for all of cosmology, folks? Anyway, x.com/smashomash is where to find us. That is where the most social media interaction happens. It's slightly less pathetic than Facebook. Still pathetic, but slightly less pathetic than Facebook. Because more people are actually over there chatting and making fools of themselves. Anyway, there's filaments. Once again, that's El Teide, Spain's ground-based solar observatory. There are a few that could get names here, mainly in the northern hemisphere. That one that's in the southern hemisphere by the polar region, that one could get a name as well. That is a truly massive filament, as it is becoming a prominence down there in the southwestern limb. And before we get to bonus features, another crown prominence happening up here in the northern hemisphere. So that's the past couple of hours from the GO 16 SUVI. That's what's streaming constantly on the homepage at smashomash.com/smashteam. There was a little lull in the coverage today because we had to update the OS on that PC. But it's back. smashomash.com/smashteam. And oh, we've got custom coronagraphs. I almost forgot. There are our custom coronagraphs. 24-hour videos featuring SDO 193 angstroms and the Soho coronagraphs. As Mercury peeks into view. Again, those CMEs are little more than a spectacular light show. Those are not expected to produce any space weather, at least at Earth. Here's the full zoom. We've added 304 angstroms to the 193 angstroms there. And there's the optimal filament wavelength. And don't get the filaments. This is a great example of filaments versus coronal holes, folks. Yeah, filaments versus coronal holes. So if you look over here, you can see two different dark features. This is a hole in the solar corona, and this is an absorption feature. Absorption feature, coronal hole. So, know the difference? They are very different features. Those filaments are a lot of material in the corona, and the coronal holes are limited material in the corona. And let's get the bonus features. Starting with satellite charging hazards. And they've moderated a little bit here. We had some mild charging hazards. They're even milder now. A little bit of surface charging hazards there in the East Pacific. Low energy electrons are building up a bit on the outsides of spacecraft. Next, it goes electron flux, and you can expect this to be quite low here, quite low, as there is a coronal hole high-speed stream about to intensify. Let's take a look and see what my prediction's been doing. There you go. Density continuing to drop, speed continuing to rise, also plasma temperature continuing to rise. So there's the GOES electron flux for the past 3 days. Expect this to be quite low. There's the 1-year graph of the relativistic electrons measured, reported by Solon.info. And there's the NOAA forecast. You can expect the next update to be way down here. This coronal hole high-speed stream is showing up at an unexpected time, either very late or very early. I suspect this is a late coronal hole high-speed stream. But it might be from the North Pole current sheet. Actually, I kind of suspect it's an early North Pole current sheet coronal hole high-speed stream, because that South Pole current sheet was featuring a super weak solar wind. So I think this is actually an early arrival of that North Pole-oriented coronal hole in the southern hemisphere. Anyway, the electron flux is measured at the F layer of the ionosphere. Let's show that. There's the ionosphere. And you can expect a lot more low-frequency anomalies in the coming day. So tomorrow's daily space weather video should feature a lot lower frequencies on this. They should be dropping off at the end of this as well. Here's the anomalygram. Its anomaly in megahertz from a 30-day median. And again, remember, folks, the magnetic field orientation, which is the BZ component of the solar wind data, is really what determines if we'll go into geomagnetic storm conditions. There's the current image, 12 o'clock universal time ionogram, 12 o'clock universal time anomalygram. Here's the WAM, the whole atmosphere model, the global ionosphere nowcast. It shows the total electron content and maximum usable frequency together, along with the anomalies for those. This should be good for both GPS and radio users. And you can see those high electron contents over the East Pacific, actually. So we love it when the data correlates, and in this case, it certainly does. It's a good day for space weather, even if it seems kind of boring. We also show total electron content. It's free electrons to about 12,500 miles of altitude. That's where your GPS satellite is. And there's your total electron content forecast, which continues to look jacked up. There's no way the electron contents are really as low as what that's showing. So let's just switch to the North American anomaly from the 10-day average. And this looks legit. So huge swings of the electron content there. Seeing high electron counts and then shifting to very low electron counts in blue. Back to high electron counts in red. And here's our latest solar imagery. So first we'll take a look at this new sunspot. It is barely showing up there and showing some umbra indeed. So at least one umbra there. It's so far it's only an alpha class sunspot. I have no forecast on that. And let's take a look at these groups. That is beta gamma class at least. Let's check that along with the continuum. That is beta gamma class. And this one here, that one is beta gamma delta class, just barely. and this one here we'll look at. Actually, we can get both of these on screen at once. So in the upper left, that one is barely beta class. It does have, actually that's actually alpha class. That only has North Pole Umbre. And the one in the center of your screen, that one is Beta Gamma Delta class. So that's what's going on. The weather all the way from the sun down to Earth. Anyway, getting even closer down to Earth, here comes the actual weather. Yeah, meteorology segment coming up. There you go. Here's the world's lowest pressure. It's this typhoon in the Pacific Ocean. And the pressure is all the way down to 941 hectopascals out there. Other areas of note are this area in the Bering Sea and a bunch of heavy low pressure systems there around the Southern Ocean. And there is a dominant low pressure here over the U.S., which we'll cover in some detail, show some forecasts. High pressure over the Rockies. Low pressure over the, what is that? That's the South Dakota-Nebraska border, approximately, where that low pressure is currently stalled. Here come the wind patterns of planet Earth. These are the surface winds of the east. These are the jet streams blowing backwards over the West Pacific. Here are the jet streams of Europe, Africa, and the Middle East, the central world. Surface winds. Surface winds of the Americas. And the jet streams. So here's that low. You can see that low is hanging out right there at the, it's really at the tri-state border there, the border between Iowa, South Dakota, and Nebraska, right in that region. And that is in control of the central portion of U.S. weather at the moment. We'll show you a closer view of that. First, clouds and fog over the entire western world from the NASA GOES Interactive Weather Satellite Suite shortwave radiation map. Clouds and fog, and here is that stagnated low. It's stalled right there. It is now loitering. Next, our weather.gov map and lots of freeze warnings over the western U.S. Colorado is freezing solid along with New Mexico and Arizona. Very cold temperatures there as Canadian air is injected deep into the southern U.S. Nevada, Utah, winter storm warnings in Wyoming continue, although that is now subsiding. Also, heavily windy conditions there around Nebraska, Kansas, and eastern Colorado. This is your wind and pressure map. That is depicting mean sea level pressure and wind. So going to have heavy winds there in the central plains for the next about 24 hours. And then a low is going to head across the U.S., re-intensify off of the coast of Maryland. Really the coast of Jersey, I should say. You'll have heavy winds in the Great Lakes in the coming days as well, especially at southern Lake Michigan. The Windy City is going to be really windy. That's Chicago. Next, pressure and precipitation for the next 72 hours. These are GFS 72-hour models. And there's going to be an intensified low there off the coast of New Jersey, but it will have little effect as it will intensify in the ocean as it combines with that low that's currently loitering over Nebraska, Iowa, and South Dakota. Temperature anomalies next. We'll have mostly low temperature anomalies here over the next 3 days for the east. Some wild temperature swings there in places like Kentucky especially, going from 12 degrees Celsius above normal all the way down to 12 degrees Celsius below normal. 72-hour GFS temperature anomaly forecast in degrees Celsius. Last but not least, the real controller of the jet stream the real controller of your weather is the jet stream. There you go, the 250 millibar winds. You can see that Canadian air at the end of the 72-hour forecast there, injecting that cold air deep into the southeastern U.S. once again, making it all the way down to Georgia and beyond. Making it all the way down to the Bahamas in about 4 days. Cold temperatures coming to the Bahamas, folks. So you can forecast beyond 3 days if you understand the way atmospheric physics works. It's just that the models don't work beyond 4 days because they are lacking the appropriate inputs. It's garbage in, garbage out, folks. If you don't have the inputs for your model, your math is right, but your model's crap because garbage in, garbage out. An old programming term, GIGO. Here's your lightning mapper, and that low loitering over South Dakota, Nebraska, and Iowa is kicking up some lightning. And let's see if we have any current terrestrial strikes here. About 320 strikes per minute on a worldwide basis. And some minor lightning activity there in northwestern Iowa. Oh, check it out. They named a town after Liz Warren. An entire county was named after Liz Warren. Who knew? Lightningmaps.org. Next time you hear thunder, I highly recommend it. We'll close out with U.S. Doppler. You want to see the full 50-state view? There you go. Clouds and fog. And there is water vapor. You can see that rotating low. A little bit of dry air intruding in there. And the jet stream is going to slowly sweep that out to the east in the coming days. Here's your recap. Dry air in the southern U.S. Less so in the north. Anyway, it's time to close this thing out. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. Do not pole vault the caldera, folks. Our finest days lie ahead. And we'll be back tomorrow. In the meantime, may that solar wind be at your back. 'Cause I'm going back to the bunker again. Lots and lots of stupid stuff. Encouragement to climb in.